Hello and welcome to another calculus instructional video. This video is about how to find the limit of a function as x approaches infinity. So up at the top of the page you'll notice that I have already plotted a function f of x equals x over x minus 1. And if we want to find the limit as x approaches infinity of x over x minus 1, you'll notice it's very difficult to use the substitution method, because if we substitute in infinity, we'll get infinity over infinity minus 1, and that is an indeterminate form. Basically, an indeterminate form happens when you have something like 0 over 0, or infinity over infinity, or something that doesn't mathematically make sense. So, here's what we're going to do. We know the limit of this is going to be the horizontal asymptote of this function. However, how do we find that? Let's take a look. Since we have an indeterminate form, let's divide everything in this function by x. So, on the top of the fraction, we'll have an x over x. On the bottom, we'll have an x over x minus 1 over x. We can reduce the top is 1 over 1 minus 1 over x. Now, when we plug infinity in, we will have 1 over 1 minus 1 over infinity. Now, 1 over infinity we know equals 0, so we'll now have 1 over 1 minus 0 over 1. So, our horizontal asymptote is at y equals 1. And that is also the limit as x approaches infinity. Now, let's take a look at some examples to figure out what happens when we do not have an indeterminate form. So, in the first function here, we're taking the limit as x approaches infinity of 3x squared plus 5 over 2x squared minus 6. Now, when we use substitution, we can plug in infinity in for x on the top and the bottom, and we'll get 3 times infinity squared plus 5 over 2 times infinity squared minus 6. Now, when we're talking about things on the scale of infinity, that 5 and that negative 6 don't really matter a lot, do they? So we can actually just get rid of them. And we'll say that we have a 3 times infinity squared over a 2 times infinity squared. Now, we can cancel the infinity squareds on the top and bottom, because we're allowed to do that now, and just take a look at the coefficients. So now we have the limit as x approaches infinity is equal to 3/2. Now, we can see that there's a shortcut. If we have something with identical powers of x on the top and bottom, we can use the coefficient rule. And that is, we can just look at the coefficients, and the ratio of the coefficients of the highest powers of x will give us the limit. Alright, now let's take a look at another example. We're taking the limit as x approaches infinity of 7x squared plus 2x plus 1 all over 3x. Now, we'll notice right off that we don't have the same powers of x on the top and bottom. We've got an x squared term on the top, but only an x to the first on the bottom. Therefore, we cannot use the coefficient rule, and it's not going to end up as an indeterminate form either. So what we're going to do is let's use the substitution, finding limits by substitution. Let's plug infinity in for x. And we'll get 7 times infinity squared plus 2 times infinity plus 1 over 3 times infinity. Now we're going to have to take a look at the relative sizes of these terms. We've got an infinity squared on the top and an infinity on the bottom. So we're only going to take a look at the highest powers of x. So now we have a 7 times infinity squared over a 3 times infinity. And we know that the top is going to be a very lot larger than the bottom because there are 2 infinities on the top and only 1 on the bottom. So we can say that the limit as x approaches infinity of this function is going to be infinity. That means it's just going to keep extending up and up and up as far as the function goes over. It will never hit an absolute limit.